everyone, welcome to Math World. This video is to discuss Cambridge International AS and N-Level Mathematics Paper 6, which is the Probability and Statistics 2 for May-June 2024, and the code is 9709/61. Let's get started. Question number 1. A bus station has exactly 4 entrances. In the morning, the numbers of passengers arriving at these entrances during a 10-second period have the independent distributions. So all these are Poisson distributions. Now find the probability that total number of passengers arriving at the 4 entrances to the bus station during a randomly chosen 1 minute period in the morning is more than 3. Okay, so now all this will be for 10 seconds, and now we are considering 1 minute. Okay, so now first of all, I will just write down 10 seconds. So it will be PO, Poisson, 0.4, then 0.1, 0.2, and 0.5. Okay, 4 different entrances. So now here, because the question says total number of passengers, so now from here I will say total is basically Poisson distributed. So when you get the total of 0.4, 0.1, 0.2, and 0.5, that is basically 1.2. And now we are considering 1 minute. So 1 minute. So 10 seconds into 1 minute. 1 minute is basically 60 seconds, which means you need to times 6. So therefore, for the 1 minute, my total is basically total passengers. It will be Poisson distributed. Here you times 6. Right, so 1.2 times 6, that is 7.2. So that is my new Poisson distribution. And now I will let T be total. Now you need to count probability that the T is more than 3. Okay, so for Poisson distribution, let's say this is Poisson distribution with lambda mean. So Px equals to x, it will be E minus lambda x over x factorial. So the x starts from 0 until infinity. So from here, when it is t greater than 3, means that from 4 onwards until infinity. So I will use 1 minus all previous probabilities. That will be probability t equals to 0 until 3. Because more than 3 means 4 onwards. So I minus all previous t value. And now when you look at the formula, actually this exponential minus lambda is a constant because the variable is the x. Therefore, in my calculation, I will factorize the e minus lambda. And in this case, my lambda is 7.2. So it will be 1 minus e negative 7.2. When t equals to 0 means that lambda power 0 over 0 factorial. That is 1 for the whole value. Then when t equals to 1, I get 7.2 over 1 factorial. No need to write because this is 1. Then 7.2 squared over 2 factorial. After that, 7.2 cubed over 3 factorial. Okay, then here you will get 1 minus all the calculations, the value of the exponential together with the brackets. That will be 0.071917. So then I will be getting 0.92808 and round up to 3 significant figures, that is 0.928. So that is the calculation for first part or first question. Okay, now for question number 2, the variable x has distribution. Normally distributed, it actually has normal distribution with mean 31.2 and variance 10.4 squared. Two independent random values of x denoted by x1 and x2 are chosen. So these two x1 and x2 are chosen from the x distribution. which means x1 and x2 will be having the same distribution as the x. Now find px1 greater than 3x2. So it means that now x1 is normally distributed with mean 31.2, variance 10.4 squared. Okay, same goes to the x2. And now you need to calculate px1 greater than 3x2. That means now here it is the same as px1 minus 3x2 greater than 0. Which means now I need to get the distribution for x1 minus 3x2. So now, expected value, which is the mean for x1 minus 3x2, that is ex1 minus 3ex2. We have this formula, eax plus by, that is aex plus bey. Okay, whenever you have the constants, you just take it out, factorize out. So that means here I will be getting ex1 minus 3x2, basically same e. So that is 31.2 minus 3 times 31.2. Then you will be getting negative 62.4. Therefore, the variance now this 3 is the multiple, okay, it's 3 times of the x2. So then our another formula is variance ax plus by, or minus, plus minus, here plus minus, it will be a squared variance x plus b squared variance y, even though here is minus by, but when you calculate the variance, it is plus, which means this is variance x1 plus 3 square variance x2. Okay, so that is 10.4 squared plus 9 times 10.4 squared. So it's actually 10.4 squared, you multiply by 10. Then it will be 1081.6. Okay, so with this, I can write down my distribution. My mean is negative 62.5 and my variance is 1081.6. So I will calculate my probability based on this new distribution. So since this is normally distributed, that means I will standardize it. Just for information, if your x is normally distributed with mean mu variance sigma squared, when we standardize, that is a z or z, then it is x minus mu over sigma, which means now here I will write p z or z greater than 0 minus the mean over square root of variance, because you divide by standard deviation. Standard deviation is square root of variance. Then here is going to be 1.897. Okay, so when you get greater than 1.897, you need to count this probability, draw the graph or sketch a graph. It is a bell-shaped curve, symmetrical at origin. So now 1.897 is on right side. Since it's greater than means a region towards right side. So in order to get the blue region, that is 1 minus all previous region, because the previous region probability is available in the normal table. Then now read the probability from the table to get 0.9711. So when you minus from 1, that is going to be 0.0289. So this is the solution for question 2. Question 3. The time taken in minutes for a certain daily train journey has a normal distribution with standard deviation 5.8 for a random sample of 20 days. So this is the n. And this 5.8 is the sigma. Okay, for random sample of 20 days, the journey times were noted and mean journey time was found to be 81.5. This is the mean from the 20 days. That means this is a sample mean. Now A, calculate a 98% confidence interval for the population mean. So now 98% confidence interval for population mean, which means it is mu. The formula is x bar plus minus z 0.01. How to get this 0.01 is basically sketch a graph. Okay, you are constructing 98% confidence interval. That means the region bounded by two lines is 0.98. So here is going to be 0.01. This is 0.01. That means this is how I get the z 0.01 over here. Then after that, sigma over square root n. This is a formula. Now, x bar is given 81.5. Okay, so since these two sides together, it will be 0.99. Okay, here total 0.99. That means now you read the table. When 0.99, the probability of 0.99, the critical region, the z value, it will be 2.326. And this is going to be negative 2.326. So I will replace my z 0.01 by 2.326. And then my sigma is given 5.8 in the question over square root of 20. The n is 20. So now the confidence interval is counted using minus first to get the lower limit. Then you will be getting 78.5. And when you consider the plus for the calculation, that is 84.5. So done for the confidence interval. Now a student was asked for the meaning of this confidence interval. The student replied as follows. The times for 98% of these journeys are likely to be within the confidence interval. Explain briefly whether this statement is true or not. Okay, this measure of these journeys. Of these journeys means that it is referring to this sample, just 20 days. But actually the confidence interval is to approximate the whole population, right? That means for any journeys, right? So that means this statement is not true. Okay, the statement is not true because confidence interval is for population. It's not for the particular sample. It's confidence interval is for population mean. And not for individual time, right? Okay, now, or it's not for particular sample. Now, two independent 98% confidence intervals are found. C, given that at least one of the intervals contains the population mean, find the probability that both intervals contain the population mean. So here you have one condition and you need to find the probability of another case, another condition. That means this is the conditional probability, right? I will write P, two intervals contain the population mean. So I just write two intervals given that at least one interval, right? That means this is probability of two intervals intersect with at least one interval. At least one interval contains the population mean. Alright, I didn't write in full. Over at least one interval. Okay, now when you find the intersection between two intervals and at least one interval, at least one means it can be one or two. So basically the intersection means two intervals contain the population mean. Okay, at least one interval, probably you can just write one or two. Or probably you can write, because we are just considering two intervals, right? So when two intervals, it means that it can be none of them has contain the population mean, probably one or two. So at least one means it can be one or two. Therefore, I can just use the total properties minus 0 interval. So 1 minus 0 interval. You can use this method, or otherwise you can just calculate 1 and 2. I will show you both later on. So that means when two intervals contain the confidence interval, contains the population mean, the probability is 0.98. Okay, so which means when P is 0.98, then the Q will be 0.02. So this is basically 0.98 for first interval, and then you multiply with the second interval, because independence means that you multiply together, which is squared, over 1 minus no interval contain the population mean. That means this is going to be Q. So 0.02, and there are two intervals. Right? Two intervals that do not have do not contain the population mean. Then here is going to be 0.961. So you can use this method to calculate, which means this part. Or another method is, okay, right after this step, you just write P two intervals. Okay, this is all over at least one interval means probably one interval contain the population mean, or is plus two intervals contain the population mean. Okay, so now two intervals will be 0.98 squared. If one interval means that one contains and one does not contain, so that means here contain is 0.98, does not contain is 0.02. But then since you are considering two intervals, so you are not sure which one, right? So it means that probably the first one has, the second one does not have, or the second one does not have and the first one does not have and the second one has, right? Has the contains the population mean. Therefore here you have to times 2 if you use this method, plus two intervals have both intervals have means that 0.98 degree 2. That is the second method to calculate this. Then you will be getting 0.9604 over 0.996, and at last you will be getting 0.961 as well. So you have two options to calculate this probability. Okay, next question, number 4a. Now, a random sample of 8 boxes of cereal from a certain supplier was taken. Each box was weighed and the masses in grams were as follows. So find the unbiased estimates for population mean and variance. So now your summation x, so you add all together. This is going to be 2044. Okay, and then summation x squared, 261 squared plus 249 squared. Just square all the values before you sum. This is going to be 522,348. So now the unbiased estimate for population mean. So that is new hat. Hat means estimated value for population mean. This is counted using sample mean. That is summation x over n. So your n is 8. Therefore, 2044 over 8. And this is going to be 255.5. That is the unbiased estimates for population mean. For variance, population variance is sigma squared, so not hat because it's estimated value. It is counted using sample variance. Formula is 1 over n minus 1 times summation x squared minus square of summation x over n. And now replace all the values. So your n is 8, therefore n minus 1 becomes 7. Summation x squared already counted, 522,348. Minus the summation x is 2044. Square it over 8. Then this is going to be 106 over 7. You can leave it in decimal, that is 15.1. So done for the A. B. The supplier claims that the mean mass of boxes is 253 grams. The quality control officer suspects that the mean mass is actually more than 253 grams. In order to test this claim, he weighs a random sample of 100 boxes of cereal and finds that the total mass is 25,360 grams. Now, first part, given that the population standard deviation of masses is 3.5, this is a sigma. Test at 5% significant level whether the population mean mass is more than 253 grams. So now H naught, since we are testing the mean mass, therefore mu. So initially 253, now you are suspecting it is greater than or more than 253. 5% significant level, this is the alpha value. Okay, now from here, since your n is large, 100, therefore we will use the, or I will say the population standard deviation is given 3.5 grams, therefore it will be normally distributed. Right? So now draw the graph. Now look at the H1 to decide where is the tail. The tail is positive, it's on the right side, which is the upper tail test because it's greater than. So this region is 0.05. So since we are using the Z test, right, the normal test, the total regions towards left side will be 0.95. So that the total probability is 1, and then you will be getting the critical value as 1.645 from the table. Now, the calculation, Z is x bar minus mu over sigma over square root n. X bar, okay, now look at here. You are given total mass. Then the mean is, the n is 100. So the x bar is basically summation x over n. So I will copy the total mass, 25360 over n is 100. So when you divide, this becomes the x bar. Minus the mu is mu at the h naught. Therefore, you are getting 253 over sigma is given, standard deviation, 3.5 over square root 100. So this is going to be 0.6 divided by 0.35. And then you will be getting 1.7143. Now round up to 3 significant figures, that is 1.71. Now check. 1.71 actually it is inside the region. So now here I will just write, since the calculated Z is greater than 1.645. Okay, I forgot to write down one statement. Right after the graph here, I should write reject H naught, which is a rejection criteria, if Z is greater than 1.645. Since now your counted value is greater than 1.645, our decision is reject H naught. Okay, so for the conclusion, go back to the question. Okay, you want to check whether the population mean mass is more than 253 grams. And now we have rejected the H naught, which means we are supporting this H1. Okay, so my decision is reject H naught. Therefore, the conclusion is there is sufficient evidence. But this conclusion is only valid at the particular alpha value. So I have to write down the alpha value to conclude that the population mean mass is more than, that's the population, (253 grams). Okay, so that's all for the hypothesis testing. Okay, now an employee says the test is invalid because it uses the normal distribution, but we do not know whether the masses of boxes are normally distributed. So explain briefly whether this statement is true or not. Okay, so actually this statement is not true. Okay, it's supposed to be normal distribution because when you look at the population standard deviation, it's given, but then you can double check with the sample size, which is 100. So even though the population is not given, I mean the distribution of the population is not given there, right? So you can just refer to the sample size to approximate to normal distribution because of the central limit theorem, right? So that means the statement is wrong or is not correct, is not true. Okay, because central limits theorem applied here. Central limits theorem basically means that large sample size, hence approximately normal distributed. Okay, so done for the part 2. Question number 5. Sales of cell phones at a certain shop occur singly, randomly, and independently. Now A, state one further condition that must be satisfied for the number of sales in a certain time period to be well modeled by a Poisson distribution. Okay, Poisson distribution other than all this, random and independently. So we have one more condition that is constant average rate or constant lambda value. Okay, that is the additional condition. Now, the average number of sales per hour is 1.2. So assume now that a Poisson distribution is a suitable model. B, find the probability that the number of sales during a randomly chosen 12-hour period, just now per hour. Okay, per hour 1.2. Now this is 12 hours. Will be more than 12 and less than 16. So now your lambda is 1.2 is per hour. So since there are 12 hours, so you multiply by 12, then that is going to be 14.4. Okay, so now for lambda equals to 14.4, and now you need to count probability more than 12 and less than 16. That means I will write x is PO 14.4. Okay, then probability that x more than 12, less than 16. So that means your x values will be 13 until 15. And now for the Poisson distribution, x is PO lambda. The probability it will be E minus lambda lambda x over x factorial. So the x start from 0 then until infinity. This is the Poisson formula. And now just replace, and at the same time the E can be taken out, can be factorized because it is fixed number, it is a constant. then 14.4 degree 13, because your x is 13, over 13 factorial. Plus 14.4 degree 14 over 14 factorial plus 14.4 to the power of 15 over 15 factorial. So here you will be getting the answer of 0.309046 and round up to 3 significant figures, that is 0.309. Now use a suitable approximating distribution to find the probability that the number of sales during a randomly chosen 1 month period. 1 month period is considered as 140 hours, will be less than 150. So now your lambda, just now 1 hour, 1.2. So 140 hours multiplied by 1.2, that is going to be 168. Right, since it is greater than 15 here, that means it will be normally distributed. So I will write the original distribution first. Let it be y, because y for 140 hours. Okay, so now it will be approximate to normal because of greater than 15. So the mean and variance for normal is the lambda, which is 168. Now you need to get less than 150. So Py less than 150. Now remember, Poisson is discrete. This normal is continuous. So from discrete change to continuous, you need to consider the continuity correction factor. So less than 150, that means it will be 149, 148, and so on for y values. So for the correction, the continuity correction factor, you can plus or minus 0.5 from 150. So it means that now you have two choices, either 149.5 or 150.5. And now this is less than means towards left side. So obviously, to include the two ticks, I have to choose 149.5. Okay, so it will be PW less than 149.5. And now, since this is normally distributed, same as just now, X is normally distributed, mean, mu, variance, sigma squared. The standardized normal random variable, X minus mu over sigma. That means now here it becomes P Z less than 149.5 minus 168 over square root of 168. Then this is going to be PZ less than negative 1.427. And now, right after this step, sketch a graph. So negative 1.427 is on the left side, and since it is less, that means the region is towards left side. And now I will reflect it to the positive part, and then it will be region on the right side, the orange region. So the orange region is found using total probabilities 1 minus all previous probabilities. So which means you will get, this is 1 minus P Z less than 1.427. Okay, and now read the probability from the table, then you will be getting 0.9232, and then the answer will be 0.0768. So that's all for this working. For question number 6, the diagram shows the graph of probability density function f of a random variable x. The graph is a quarter circle entirely in the first quadrant with center or region and radius a, where a is a positive constant. Elsewhere, fx equals to 0. Now a, show that a equals to 2 over square root pi. So from here, we know that area, or I would say the total probabilities equals to 1, and this is equals to area under the curve. So now, for the area under the curve, since this is a factor, I would say that this is a sector. Okay, this is a sector. If you still remember, whenever given a sector here, this is the R, here is theta. The area is half R squared theta. So the half R is my A, because the center is 0, 0. So radius is A. So R is the A squared. The theta is half pi. Okay, so pi over 2. And then this is equal to 1. So from here we need to show the A. Therefore, I will get 1 over 4 pi. A squared is 1. Hence my A squared is 4 over pi. Now, to get the A, I will take plus minus square root. This is going to be plus minus 2 over square root pi. And now, given in the question, the A is a positive constant because it is a radius, or obviously from the graph, A is on the right side of the y-axis or the f-axis. So A is greater than 0. Hence, your A is going to be 2 over square root pi. So with this, we have shown the A value. Okay, so now part B, show the fx equals to this. Right, now since it is a quarter circle, right? So now for your information, a circle, the equation of circle with center AB and radius R. Okay, that is x minus a squared plus y minus b squared equals to r squared. Now, when you look at here, the center is origin, radius is a. That means now center, origin, radius is a. So now my equation becomes x minus 0 squared plus y minus 0 squared equals to a squared, or x squared plus y squared equals to a squared. And now this fx, okay, this fx is actually my y, right? Normally we write x and y. So now I will change my y into fx. Therefore, I will get fx squared plus x squared equals to my a. Okay, my a already found just now. A squared is 4 over pi. So here I will just write 4 over pi. Therefore, your fx squared equals to 4 over pi minus x squared. And then my fx, right, when you look at the graph here, it's always positive. The graph always above the x-axis. Therefore, you just take positive of the square root. Okay, so with this, I have shown the fx. Now show the ex. So ex is basically integrate from 0 to a, because your fx is defined, like let's see here, your fx is defined for the x between 0 and a. So now the definition for ex is you integrate the x values, then x fx. So now here I will write 0 to a, x, my fx is square root 4 over pi minus x squared. Now to integrate this, right? So you have to, now a, I will replace my a. I already found my a. A is 2 over square root pi. Basically, here I should write it is between 0, and 2 over square root pi inclusive. So that means here I need to integrate 2 over square root pi. Okay, so when you need to integrate this, we need to use the substitution method. Let u equals to 4 over pi minus x squared. Then now du over dx, first term becomes 0, second term is minus 2x. And then now here, I can combine this x with the dx. So now du equals to minus 2x dx. So x dx is negative half du. And I need to calculate my u values. So when x equals to 0, my u is 4 over pi. When my x equals to 2 over square root pi, then my u equals to 4 over pi minus square of 2 over square root pi. That means this is going to be 0. So now I will get integrate from 4 over pi to 0. So the x dx will be replaced by minus half du. So I factorize the minus half and write the du at the back. Then the square root becomes square root u. Okay, so now here where I need to integrate, basically we need to add 1 degree. So integrate x degree n dx, that is x degree n plus 1 over n plus 1, then plus c. This is without limits. Now here I will get u power half. Half plus 1 is 3 over 2. Divide by 3 over 2 means you times 2 over 3. Then limits 4 over pi to 0. Then now here, the minus half and 2 over 3. Okay, you can just simplify. The over 3 you move out. That will be negative 1 over 3. Then replace the u by 0 minus 4 over pi with degree of 3 over 2. Then now we need to prove this form. 8 over 3 square root of pi cube. So here minus this minus 1 over 3 times minus, it will be positive 1 over 3. Now 4 to the power of 3 over 2 is basically 8. Then the 3 over 2 bring in because basically it is like this. So I will get 1 over 3, 4 to the power of 3 over 2 divided by pi to the power of 3 over 2. Okay, because we have this formula a over b to the power of m, that is a power m over b power m. So now here I will be getting 1 over 3, this is 8, then pi power 3 over 2. The over 2 means a square root of pi cube. So I combine everything, that is 8 over 3 square root of pi cube. So that is our EX. We have shown the EX here. Okay, now next question, number 7. Every July, as part of a research project, Rita collects data about sighting of a particular kind of bird. Each day in July, she notes whether she sees this kind of bird or not, and she records the number X of days on which she sees it. She models the distribution of X by binomial with n31, and P is the probability of seeing this kind of bird on a particular chosen day in July. Now, data from previous years suggests that P equals to 0.3, but in 2022, Rita suspected that P had been reduced. She decided to carry out a hypothesis test. In July 2022, she saw this kind of bird on 4 days. Now A, use the binomial distribution to test at 5% significant level whether retest suspicion is justified. Okay, so from here, your H naught P equals to 0.3. But she suspects that P had been reduced. That means H1 P is less than 0.3. And now 5% significant level means 0.05 for the alpha. Now your X is basically binomial distributed with mean 31, and then the P here, the P is the P at the H naught. That means it's 0.3. So from here I know that the probability of success is 0.3, probability of failure Q is 1 minus 0.3, that is 0.7. Okay, now I will write down the rejection region, rejection criteria, region H naught if. Now look at here, this is less. Therefore, your probability of X less equals to. Less equals to is because of the less in the H1. Okay, now less equals to what value? 4 days. Okay, so less equals to 4 and less than the alpha value. Always less than alpha value, then you reject H naught. So now we need to calculate P X less equals to 4. So for binomial distribution, X is binomial and P, the probability equals to NCX, PX, QN minus X. So the X starting from 0 until N. So now X less equals to 4 means that it will be 0 to 4 for the X values. So you need to calculate all these probabilities. So when PS goes to 0 means that no success, means all failures, 0.7 to the power of 31, plus 31C1, 1 success. And then 30 failures, plus 31C2, so it means 2 successes, 2 days she can see that kind of bird, 29 failures, then 31C3, 0.3 cube, 0.7 to the power of 28. And lastly, 31C4, 0.7 power 4, 0.3 power 4, 0.7 to the power of 27. So now we calculate all of this. It will be, if I write down all, the individual values, all the individual values, so you will be getting this. Okay, then here is going to be 0.0239 when you round up. So now, make the conclusion based on the rejection criteria. When less than 0.05, you reject H naught. So obviously this value is less than 0.05. So now our decision. Okay, so here you write, since Px less equals to 4 is less than 0.05, therefore reject H naught. This is a decision. So reject H naught. What is the conclusion? Your conclusion C will be based on whether retest suspicion is justified. So it means we have rejected H naught. That means there is sufficient evidence. Right? Probably I just write here because of limited space. So I just write here, since Px less equals to 4 is less than 0.05, so reject H naught. There is sufficient evidence at alpha equals to 0.05 to conclude that Rita's suspicion is justified. Okay, so that's all for this solution. Now in July 2023, she noted the value of X and carried out another test at 5% significant level using the same hypothesis. Calculate the probability of type 1 error. Okay, so P type 1 error equals to probability of reject H naught, given H naught is true. Now, from the previous calculation, we know that when it is probability of X less equals to 4, right, we get the value which is less than 0.05. Now, what happens when it is X less equals to 5? So we are not sure, so therefore we have to calculate. So Px less equals to 5, that is same as P up to 4, the previous calculation, plus Px equals to 5. Okay, so since we need the previous calculation, probably here I give more decimal places. That means you should get 9036. So better to give more decimal places, then you round up. So now I need this value. I need this value here. Okay, and then it will be 0.023936 plus 31C5, 0.3 degree 5, 0.7 degree 26. Then here you will get total of 0.06266. So it's recommended to give more decimal places before you round up to 3 significant figures, because we might need that value in the next calculation. So now I round up 0.0627. So this value is greater than 0.05. So when greater than 0.05, go back to the decision here, the criteria. Reject H naught if it is less than 0.05. That means now here, this is accept H naught, or do not reject H naught. So it means that when we consider X, at least X is at most 5. Okay, less equal to 5 means at most 5. We do not reject H naught. But our type 1 error is defined as reject H naught. Therefore, this is same as Px less equals to 4. So this property you just copy from the previous part, which is 0.0239. So this is how we decide the probability of type 1 error. Now, Rita models the number of sightings Y per year of a different, very rare kind of bird by the distribution, okay, binomial. First part for the C, use a suitable approximating distribution to find Py equals to 4. So since your N is 360, right, I will write probably this is Y, because it's mentioned in the question Y. So Y is binomial distributed, N is 365, P is 0.01. So now your N is 365, P is 0.01. So now NP will be 365 times 0.01. That is going to be 3.65. Okay, and you are given a hint, suitable approximating distribution. So basically, when the N is greater than, I will write like this. This is greater than 50. Okay, so from here, your P is 0.01. Therefore, your Q is 0.99. Then now here, your NP is less than 5. Therefore, I need to find my, it will be Poisson distributed, okay, because your NP is small, right? if your NP is greater than 5, then it will be normally distributed. So that means now here your Y initially binomial distributed with 365 and 0.01, now approximated to Poisson because of the NP is less than 5, even though the N is greater than 50. So the mean is 3.65. Now, for this case, binomial is discrete. Poisson is also discrete. So both are same type of distributions, right? I mean same type of variables. Okay, both also discrete. Therefore, or same type of the Y and W are same type of random variables because both are discrete. Okay, therefore we do not need to consider the continuity correction factor. Okay, that is only happens when you are approximating a random variable to another type of variable which is discrete to continuous. Okay, so now discrete to discrete, no need. Therefore, we can just direct calculate. So now we need to find Py equals to 4. So Py equals to 4 is basically same as Pw equals to 4. And since this is Poisson distributed, so just use the formula E minus 3.65, 3.65 to the power 4 over 4 factorial. Then you will be getting the answer of 0.1922 correct to 3 significant figures, that is 0.192. So done for the C first part. Okay, now part 2, justify your approximating distribution in this context. So very simple, just write down the n value, which is 365, is greater than 50, and then the NP is 3.65, which is less than 5. So this will be your justification. Right? Therefore, Poisson approximation to binomial. Okay, so I have completed the whole paper and also comes to the end of the video. Thanks for watching. Please subscribe to the channel and share this channel with everyone if you enjoy watching my video. And also stay tuned for more upcoming videos. Thank you everyone. Bye.